Good morning, everybody. The webinar will be starting shortly. I'd like to just check that everybody can hear the sound from your end, please. If I could have just a couple of people respond on the chat. Thank you. I've got a couple of hand raises and a couple of comments there. That's great. We'll be starting at 11 o'clock. Good morning, everyone. Welcome to today's webinar, Fire Engineering for Resilience. My name is Melissa, and before I introduce our speaker for today, Dr. Jim Glockling, I've got a few housekeeping notes. If you have any technical, IT or sound issues with today's webinar, please raise your hand or use the chat facility panel, and I will do my best to assist. During the presentation, all participants will remain in listen-only mode and webcams are not enabled. We are going to finish within the hour, and as this is a technical webinar which outlines new guidance, we will not be operating a live question and answer at the end of the session. Instead, if you would like to comment or have any feedback on the document, please use the chat facility throughout the webinar, and I will compile the comments and review with Jim, with any necessary clarification or feedback being sent to you in your follow-up email. We've kindly been awarded CII and IFE CPD for this webinar, and details of this will also be sent to you in the follow-up email. Finally, all of our webinars are recorded and are available for listen again via the members area of the FPA or the Risk Authority website, along with the presentation slides. If you are not an FPA member, our membership is competitively priced from £135 per year. And as a not-for-profit organisation, this charge ultimately is fed back into the organisation to help fund the research and production of documents like you're hearing of today. So we hope by becoming a member, it's useful spend for you and your organisation, but also for the greater good of fire safety too. So I'm now going to hand over to Jim to start today's session.
Right, thank you very much everyone, and thank you for the opportunity to talk today on the new guidance that we've really released on fire engineering for resilience. Now, those of you who know the FBA and in particular Risk Authority, there will be bias in any talk like this, as we are obviously great promoters of resilience, and particularly the preservation or property protection in the sort of critical fields that we see, particularly in business and those providing services. So there will be some bias, I'm sure, but very happy to hear your feedback on that as we go through the talk. It's obviously the main focus of a talk like this is fire engineering is a admirable toolbox of parts to achieve whatever goals are set, but all too often the goal set is that of only the, if you like, the mandated minimum requirement, which for our purposes we view as a very low and grey bar, which principally is really trying to ensure evacuation of a building before it collapses, with very little more mandated component aside from that. But to introduce resilience, there are mechanisms and means to do it, and fire engineering, the fire engineering process is a very good way of achieving it. And resilience at the end of the day is really the process by which you can avoid, limit, recover, and improve the protection of any business or provision of services that wish to be resilient against. Now, really one of the ultimate cases for resilience is in the heritage sector, where the remit would appear on the face of it very simple indeed, that the asset must survive. But I have to confess, I sit in many talks about fire engineering for heritage protection, but at the end of the day, many of this, its focus is generally still on the people, even to the point where you see cases presented where people have estimated how long it might take a 400-year-old door to burn through, so that people may egress safely from behind it. And really, that's not the point. There you're really sacrificing the very asset that you're meant to be protecting to ensure what at the end of the day is just another life safety process, which would be akin to that provided for any hotel or shop. So really, it's about re-establishing the focus as to what you're trying to achieve. And resilience is generally, not considered or all too rarely considered at the end of the day, but certainly since Grenfell, we're seeing it much more in the forefront at the end of the day. So certainly when you look at the structures in place to make buildings compliant, certainly with an approved document B, it is a life safety code very explicitly, and actually in its development you're not really even allowed to engage in terms of business and property protection. Fire engineering at its inception was really always meant to move on to more property protection elements, but is kind of rather slow to do so. And really building information modeling, or BIM, certainly in the original writings of Richard Saxon, the viewpoint is that in the fullness of time, really insurers should be able to insure buildings from the BIM model itself, such a great understanding of the building achievable. But it is by and large neglected, but certainly post-Grenfell now seems to be the day to discuss it an awful lot more. First and often last lesson on building resilience is really the tale of three little pigs. And as you can see in this picture, in the case of wolf-related risks, if you were choosing a building method, certainly it'd be preferable in this case, following this story, to go for bricks rather than stick or straw. But interpretation depends very much on what the design objective is. And this is a nice way of highlighting certainly the difference between maybe an insurer perspective or a business owner's perspective and the government perspective. So government's perspective, generally its mandate is to look at life safety exclusively. And the one thing that's apparent from that picture is in none of those building methods have any of those pigs died? And so what's acceptable to one party might be less acceptable to another. It depends very much on what your standpoint is at the end of the day. To actually deal with business and property protection really requires an extension of scope outside of what we might be used to in approved document B or any of the sort of mandated requirements for life safety. And it doesn't just influence the scope, but it can also curtail some of the methods that you might use to solve some of the problems at the end of the day. So really, in addressing business and property protection, it needs to consider what the post-evacuation needs are. And whilst it might sound strange, it does extend to, well, how is the fire going to be put out? How might the compartment that's been lost be reinstated? How might the business be reinstated? And what durations might be set to get it back up to being fully operational? We also need to consider things which might not normally be considered in a normal fire engineering design, such as malicious attack and arson, human vulnerabilities and fallibilities. From my time working for Burgoyne's, it's all too often it might be some of the very human solutions that you put in place that turn out to be the source of the problem at the end of the day. And you'd be probably amazed at the number of night watchmen that might actually, at the end of the day, set fires for themselves to discover, to feel more worthwhile in their roles, that then gets out of hand. Fire ingress from external sources is another important element, particularly with some of the new building designs that we're seeing, which is currently not really considered fully in current codes. Consideration of susceptibility, and you will know, and we'll look at some of them, the sorts of fires which we've had recently. You can almost write the script that at the end of the day someone says that the building wasn't put together properly, and that's why it ended up on the ground. But really, dealing with resilience, you need to think about the susceptibility for imperfection and its response to that imperfection in your original design. And if there's a more robust and resilient method that can be selected, then maybe it would be wise to do so. Abnormal operation and the world being imperfect. It's an interesting feature that obviously fires generally start because something bad has happened, yet we assume there's going to be perfect response from the responding systems to deal with that fire. And seldom is that the case. We also need to consider about third-party help as well. And whilst many plans draw upon an assumed level of response from the fire and rescue services, we really do need to bear in mind that actually the fire and rescue services don't actually have any responsibility for the protection of business and property, although obviously they are immensely valuable and do very well subject to being there and able to have an impact safely. But currently in the risk assessment, they are certainly not deemed to, they shouldn't be taking any risk to save business and property, and also can introduce safety factors also. Now, the process for actually introducing business resilience into business property resilience into the fire engineering process is well documented in BS 7974, and this work was done by Peter Wilkinson, formerly of the FPA, now of Pyrology, and it's embedded firmly within there, and this diagram shows it quite nicely in how for any new building you might have the architectural driven requirements of form and function, the legislative requirements of life safety, and it really introduces this third string of business and insurance driven requirements, which is business resilience, to create the fire safety objectives for the fire engineer to design to. But really the starting point for all of this and the message to anyone that's listening, I see we have a lot of accommodation providers listening in at the moment, is really you need to get involved at inception of the buildings and create the building that protects your business or your reputation or your ability to deliver services as best you can from the start. And what we do find is many of these good decisions can even be cost neutral. Now, inevitably, we're going to end up talking about construction materials and perhaps a preference for non-combustible ones in the types of occupancies that would benefit from that. But often as not, we do find that the decision of what a building gets made out of at the end of the day, there is no involvement from the client or even basically the architect at the end of the day. That can come down to the contracting firm and what they're used to building in. And I think there is a need for influence throughout the whole supply chain from the customer forward to end up with a building that best protects your business and best serves what you're trying to achieve at the end of the day. The starting point for this is you need to be able to tell the fire engineer what it is you're actually looking for. And a normal part of the business continuity planning is the conduct of a business impact analysis. And this business impact analysis takes a grassroots look at the services that you're trying to provide and the dependent resources, and then takes a look at the impact of the removal of those resources through losses of different types, and fire might be one of those. And then having considered those, the work is to then consider what components of those issues or those things identified in the business impact analysis can be ameliorated through the building design features that the fire engineer can influence. Now, we keep using the term business, and perhaps that's incorrect. Really, business, we can be talking about financial impact, provision of services. So while schools, care homes, hospitals, not necessarily businesses, they're providers of services. These are all interchangeable phrases, but preservation of heritage, social, and reputational can all be sort of categorized under these headings. Now, what this will result in at the end of the day is really probably a higher level design objectives. Now, these are quite crude, whereas obviously the mandated ones ultimately at the end of the day are ensuring that the building is evacuated before it might collapse, and as an assurance of life safety, and perhaps supports the safety of responders also. But if we think in the biggest picture, a manufacturing firm might want to lose no more than 20% capability to a single fire event. Now, that's a nice rounded thing, and probably a lovely task to apply normal fire engineering tools to. For a school, no more than 200 pupil teaching hours to be lost in a single event. For income to not be reduced by more than 80% for no longer for a period of time. Hospitals, heritage, we can set a higher level design objective to get creative around in any proposed solution. And the design might achieve this at the end of the day by, in terms of business, it's not uncommon to separate assets into different compartments, increase passive capability in high-risk areas, and the use of suppression systems. So we've released this guide, which basically it assists with this third string of business insurance-driven elements. But what we've also introduced here is really a clear overarching structure on the solutions that you find things. Now, there's a certain beauty in this. It's borrowed heavily from military asset protection, but it's easily applied to business, building, service provider, heritage asset, anything, and actually not even just for fire, flood, security, weather. It works for everything. But it considers resilience or survivability in three subsets. That is susceptibility to being involved in a fire in the first place, vulnerability to damage from a fire once started, and recoverability from fire damage after it's extinguished. Now, this is also providing a pecking order, because really the solutions, we know to avoid having a problem should be a preferred solution than dealing with a problem once you have it. So really, solutions which fit into these three categories should be adopted in that order also. And if we wanted to look at this graphically, well, it looks complicated at first. On the left-hand axis, if we talk about really capability, we go along at 100%, and what we're trying to do is to stay at 100%, to not have a fire in the first place, and this is susceptibility, avoidance of fire being an issue at all. However, if we do have a fire, what we want to do is to limit the impact of that fire and for it not to take us down to total loss or business critical levels of damage as described by the dotted line in the vulnerability section there. And then having really survived that with a business still intact, we need to recover. And often businesses actually fail in the recovery period afterwards. So the fire's out, but for whatever reasons, you just don't get better after it, and that's the recovery period. So that's the model. I say this is borrowed from military discipline. I mean, simply put, in the protection of a warship, this might be used in terms of susceptibility. The measures to reduce that might be radar jamming, don't be seen. If you are seen, don't be identified. And if you are identified, stay out of range, so a missile can never hit you. In terms of vulnerability to weapons attack, if a missile does hit you, then rigorous compartmentation and splitting of assets hopefully allows you to remain capable and doesn't send you to the bottom of the sea. And in terms of recoverability, it's your ability to deal with all the water that might have come in the ship and get that out. Again, so you can recover and remain a viable fighting platform. So I think you can see how it fits in and can be used for any application. In terms of fire, though, susceptibility, let's look into measures that reduce likelihood. Use of non-combusting materials is probably quite obvious in that non-combustible also means non-ignitable. If you can't ignite it, you don't have a fire. Preventative management, predictive detection systems. Increasingly now we're seeing nice systems which will detect fuel leaks before they actually manifest as fire, and automatic controls can come in place to stop it ever happening. Design simplicity, security, obviously, in the case of arson. So that reduces the likelihood. In terms of vulnerability, once a fire does start in a building, we want to reduce the extent of the damage. And really, that's the point of compartmentation, provision of suppression systems, detection alarm systems. Early warning means early action. Provision of first aid firefighting equipment. If fire can be managed safely when small and there's equipment around to do so, then use it. And duplication of asset is another key feature also. And certainly in the business realm, where you have a number of manufacturing lines, it's not uncommon to either place them in separate buildings or put a very resilient fire barrier between the two, so that you will only ever lose one in any event. So you never lose more than 50% capacity. And then recoverability, recovering what's lost. Really, it's the firefighting support systems. What inbuilt features have you put in so the fire service can help and assist? That goes for vulnerability too. The level of fire service response there is, a salvage plan, a good business continuity plan, and possibly even the insurance vehicle that has been adopted to assist with recovery post-loss. So hopefully there we provided a framework which any measures that are adopted can be put into and described very clearly as to what it seeks to do at the end of the day. Now, if you look at some recent examples of fire loss, we have one in the retirement complex in Crewe, the Bristol Premier Inn, and obviously some London flats. All of these burnt to the ground, and really the nature of the reasons behind these, certainly a contributing factor will be their construction method, which I think in the case of these were light timber frame or SIPS panels, so a large combustible component. No doubt investigations might well have found that fire stopping might have been inadequate in them, and so we know that they might be susceptible to being imperfectly put together. But if we compare these against the categories we've just discussed, in terms of susceptibility, combustible construction methods are more susceptible. Unachievable design detailing, an increasing issue with some construction methods, and fire ingress might not have been considered, certainly in our building regulations. Are they vulnerable? Well, vulnerable due to combustible voids and poor compartmentation, external fire spread, and I don't believe any of these were sprinklered. And when it comes to recoverability, well, there was too little left of them in this case. So a challenge too great for anyone to assist or anything to save afterwards, aside from entire rebuild. Now, maybe I'm straying from talking about fire engineering here, but if you stick to what is perhaps a normal remit to design to of the mandated minimum requirement, all of these buildings were evacuated before they collapsed. Nobody died, and at the end of the day, these could be probably viewed as successes, although it does seem like a rather strange use of the word success when there's nothing to save after, when there's nothing left. But nonetheless, this is where we are with the way that our regulations currently conducted and the complete divorce between life safety and property protection. And we need to think about this in terms of a business. Is the retirement home still trading? What disruption was faced by the vulnerable occupants afterwards? Now, in care homes, housing the vulnerable, certainly a change of accommodation with people very vulnerable, can be a life-ending event, such as the stress used from this. What was the business impact on Premier Inn, and of course to the occupants and owners? What did they lose? Did they expect more at the end of the day? Now, it's not uncommon when I'm talking at various fora about construction methods. I'll get faced with questions from people who work in the school, the care sector in particular, and they'll basically say, well, why does the government allow us, allow buildings to be constructed in this way, that are going to perform this way? But the harsh truth is, the government allows many freedoms for you to build out of whatever materials you like. And actually, it rests with you to decide what the best materials and methods are to support your business. That is not, doesn't fall at the government's feet to decide. So really, there's a bit of a management failing here in not getting involved early enough. And I think that comes down to really quite a lack of awareness. Our regulations do have no property protection remit. They've got no business protection remit. It is a low bar set just for life safety. And at the end of the day, the designs, methods, and building material products vary greatly in their ability to deliver resilience, and better choices could have been made if only people knew to ask. And many of these choices are actually cost neutral, as we mentioned at the previously. So why does it generally get ignored? Generally it gets ignored because it's not mandated, and there's a perception that it's going to cost a lot of money, and or more money than there might be available, and that may indeed be the case. But we need to consider the role of the managing director here, or whoever's commissioning the building, whether it be school governors or whether it be care home operators. You are a business, and whilst you may not be looking for income, it might be provision of services, you have responsibilities. We often see this term that 80% of businesses affected by a major incident close within 18 months, but actually we could word this slightly more harshly, unpopular as it is. 80% of businesses affected by a major incident show themselves to have been incompetently managed within 18 months of the event. Now, why do I say that? Well, actually, if you go to Companies House website and look at what the role of a managing director or someone with responsibility for an organization has, they've really got three things to achieve: to make profit or provide the services that you're meant to not hurt the people or who are working for you, to operate safely, and to act in the long-term interests of your employees and stakeholders, and that is business resilience. So there is a very clear mandate to do something about it, but this third element, by and large, does get ignored, and I think we see that manifest in some of the building designs that we see, and just being, made of inappropriate materials or lacking features that we might think there when you put an insurance hat on and think about protecting the business itself and having something viable after a fire. So, but we are slightly hampered, and this will be an unpopular slide, I'm sure, to the fire engineering fraternity about there, is we can't really talk about this without talking about the difference between fire engineering and value engineering. This talk is not a criticism of fire engineering. It is an admirable toolbox to achieve whatever aims are set. But the problem is that fire engineering has been used to actually save cost at the end of the day. And here is one such website offering, where this the provider here is basically assisting people to actually reduce the levels of compartmentation, reduce the requirement for sprinklers, allow single stairways to serve both residential and commercial floors, reduce the fire rating of facades. Post-Grenfell, this now looks all very distasteful indeed, but I think you can see the impact that cost has on building design at the end of the day. The driving down of costs is one thing, but I think if we've learned anything post-Grenfell, there is now a difference between what you can get away with and what you should do as a responsible building provider. So let's focus now just on the guide itself. I'm not going to go through it in huge detail, but it's set in a quite a straightforward format, and what it basically is providing is an aid memoir to just see, have you addressed these things, which all these elements, which might be uncommon to those designing just to a normal, compliant building, and just have you highlighted each or addressed each of the issues that there are that we know can build business and property protection at the end of the day. And as we go down the list there, have you thought about it, and have you thought about introducing it as part of the fire engineering process? Has the company done an impact analysis, and have you consulted various parties on your way down? So if we just look at these very quickly, there is a checklist. I'm just referring here to the checklist that's at the front. There is greater detail throughout this short document on each of these elements. So part one, it's really the 12 commandments. I guess part one is, have you referred to and introduced business and property protection as part of your design? Has the customer provided a business impact analysis for you to consider, and what contribution you can make to ameliorating some of the issues that it may bring up? If the customer doesn't have a business impact analysis, which I've got to say, when we look at the uptake of business continuity planning, is highly probable, have you assisted them by directing them to sort of products and services which can help to do this, so that you have something to go on? Have you involved the customer's insurer? They can be quite a wealth of information and assistance. And then ultimately, have the design objectives been modified over and above those required in law for life safety to discuss things like curtailment of financial loss to subcritical levels, to always have a certain level of redundancy in the design, to have separate fire compartments, to limit fire spread, to encompass a means of putting the fire out, to have assessed the timescales for recovery, and looking at overall fire impact. This is just a checklist that gets used. And then in the fire engineering design, has the possibility of arson being considered, that fire may break into a building from outside, that it may spread over the outside of the building, that really the security and access of personnel and visitors can actually contribute to the risk factors present in the building, and the potential for and consequence of, well, we say labour relation issues, but actually a high dependency on people. What about flood, out of hours operation, secondary uses of the building, potential future use of the building, and change? But these might be unfamiliar to a certain group of people listening in at the moment, but it's very familiar, certainly in insurance areas, that these are things known to produce vulnerabilities. And then we have a look at how these things might have impacted the design of the building. in terms of product selection, passive capability, the provision of active fire suppression systems, even routing of key services, point 8 there is actually quite an important one also. As we look through some fire engineering designs, we can see the partial adoption of standards. Now, this is where a fire engineering design does decide that maybe a sprinkler system is required, or a water mist system is required, or some form of passive fire protection is required. It's important that these standards are used in full, because to deviate from them can change quite radically the inferred level of protection that should be inferred from them. And this is this is sort of particularly prevalent where in the deployment of things like sprinkler systems, where the engineering design may actually change the amount of water that needs to be stored, just to the amount of water that can be accommodated on site, or the water delivery rates. But inferred from it is that it seems to be that the sprinkler system will remain as equally effective. And the bottom line is it won't. So I think we do need to ensure that where standards are used as part of the design, they are used in full as quality standards. Point 9 is that efforts in the design have been made to reduce dependency on fire and rescue services and employee intervention in terms of control, detection, and fire intervention. It is incorrect to assume that on every case the fire and rescue services are going to be prepared to turn up, on a white charger and take huge risks to save your business and property and your property. It's not the case, and it should never have been. It's never the case. But obviously, they can help out where they can do, and it's safe to do so. There's also a need in point 10 to understand what the local fire and rescue service response policy is to automatic fire alarm systems. Now, this may be, many of you may be unfamiliar, but in this country we do have a terrible problem with false and unwanted fire alarms, and one of the mechanisms used to cope with this is to call challenge, or to just not turn out for alarms of this type. And so any design would need to check this, otherwise you could invest quite heavily in equipment only to find that the building is evacuated and you stand outside it assuming that the fire and rescue service are turning up when they're not. It may require an additional 999 call to make that happen. But again, on the subject of false alarms, unwanted and false alarms, there are types of fire detection equipment which we would call high integrity fire detection equipment, which we know can radically reduce false alarms and improve fire identification, and may invoke a call much earlier and with much more reliability and the propensity to turn out. And also, it's important in any design that actually some sort of assessment of fire and rescue service response has been made in terms of time, weight, and probability, where you are depending on it to protect your property or business. It's not straightforward, but tools do exist to do that. So those are the basic sort of 12 areas that the guidance gives. The guidance points to assist the introduction of business and property protection measures into any fire engineering design. And at the end of the day, it's hoped that this guidance will provide a framework for engineering for resilience, provide a solutions pecking order, so focus first of all on preventing a problem in the first place, then dealing with the vulnerabilities, and then dealing with recoverability. It ensures customer input and awareness. Now, many of you listening in do procure buildings, and certainly it's FPA's view that there are certain construction methods and requirements for sprinkler protection should be mandated for against what the building does at the end of the day. I mean, certainly a building that's a single dwelling is very different from something that is a school and very, very different again from something which is a care home. And perhaps there is an appropriateness of building method for one which might not exist in the other. And really, anyone listening, start to get engaged with what your building is going to do, and to challenge challenge how it's going to be put together, and ask what can it do for your building. And hopefully at the end of the day provides an assessment that will be meaningful to owner and insurer alike. And with that, I think that's probably a fairly good place to end. As I say, it's a relatively simple document. It's available from the Risk Authority website, entirely free of charge, and I hope that it may serve your purpose as well. Just by way of feedback, we had around 450 people registering for this webinar, and I hope it has proved valuable to all. Thank you very much indeed.
Thank you, Jim. Just to finish off by saying we thank everybody for attending, and if you're interested in any forthcoming webinars or events the FPA are doing, or indeed access to the latest documents that we produce, either visit the FPA website or subscribe to the e-newsletter, and you'll be updated about these resources as soon as they're available. Thank you again for attending, and we look forward to seeing you soon.